Hi, my name is Hengameh Pourkarim. It's November 22nd, 2025. This is my presentation on combined spectral problem. I am part of group number 18, number 5. Um, the molecular formula that I was given was C17H14O. And the first thing that I did was calculate my degree of unsaturation with the formula 2n plus 2 minus x divided by 2, where n stands for the number of carbons that I have, um, and x stands for the amount of hydrogens. In this formula, I calculate any O's in my molecular formula. So going through that calculation, I was able to calculate that my degree of unsaturation is equal to 1. This typically means that there is either an aromatic ring in my compound or there's a double bond that's present. The next thing that I did was I went through my IR spectroscopy. I saw that my waveforms were around 3000, the first waveform set right here. This shows that there is some CH bonding stretches present. The next waveform that I evaluated was the one around 1700, which is typical of carbonyls. So I know that there's a C double bonded to an oxygen somewhere in my compound. And then all of these waveforms from 1200-ish to like 1500, that's mostly CH3 bending. The next thing that I did was, well, first, this is what I propose is my molecular structure for the molecular formula that I was given. Um, I can tell by looking at this that there are 6 unique carbons in my molecule that are present. Because there's only 6 different waveforms, even though I have 7 carbons in my compound, which tells me that 2 of the carbons are completely identical. Here at around 205 or 208, this is going to be my C double bonded to my oxygen. Um, Around 42 is going to be my CH right here. That is connected to my CH3s on the isopropyl group. The next waveform is going to be around 33. I believe that's the CH2 right here. That's right next to the carbon that's double bonded to the oxygen. Next one is 30, which is this CH2 right here. Next one is 26, which is this CH3 here. And last but not least is the 22 waveform, which you can tell is at a higher peak. I believe those are the 2 carbons on my isopropyl group that are identical to each other. Last but not least, looking at my my proton NMR, I was able to find that there is a the waveforms here at around 2.3, 2.4 are it's a triplet set. I believe those are for the hydrogens that are uh, right here, right next to the carbonyl group. Um, The next one is around 2.1. It's a singlet and it represents 3 hydrogens. Um, I believe that that's for the CH3 right here. Um, uh, the next one is for 1 hydrogen. And I believe that's for this carbon right here on the isopropyl group. Um, The next one is around 1.5 for 2 hydrogens. I believe that's for this middle CH2. And last but not least is this doublet that represents 6 hydrogens, and those are for my 2 CH3 groups on the isopropyl. Okay, that's my presentation on um, this combined spectral problem, and this is my proposed structure of my compound. Thanks so much.